Hey there, Space Cadets. Buckle up, because today we're ditching the tour bus and venturing off the cosmic map. Think of this as a deep dive into the universe's oddities. We're talking planets where it rains, molten rock rings that could put Saturns to shame,
Definitely.
and rogue planets roaming the galaxy like cosmic nomads.
Right.
Welcome to Cosmos in a Pod Space and Astronomy series.
Okay, so let's unpack this a little bit. We all know the basics, right? Stars are giant fiery balls of gas, and planets are the cooler kids that orbit them. But what if I told you that some stars act more like flickering fireflies,
Huh?
and some planets have rings so large they dwarf our entire solar system?
It's true. What we consider normal in our little corner of the universe is just a tiny fraction of what's actually out there. And
That's
that's what makes exploring these cosmic oddities so fascinating.
yeah.
It expands our understanding of what's possible and challenges our preconceived notions about how the universe works.
Right.
Here's where it gets really interesting. Let's start with a planet that's been generating a lot of buzz lately, T Garden B. It's been touted as one of the most Earth-like exoplanets discovered so far, but with a twist. This potential neighbor is tidally locked to its star,
Oh, God.
meaning one side is in perpetual daylight and the other is shrouded in eternal night.
Imagine a world where you could choose between a permanent tan or a perpetual nightlight. The catch. Those choices come with extreme temperatures, scorching heat on the day side and freezing cold on the night side. It makes you wonder, could life even exist in such a bizarre environment?
Now, you mentioned Tea Garden B is considered Earth-like, but with that dramatic temperature contrast, it sounds more like a cosmic Jekyll and Hyde situation, right? So what makes scientists think it could be habitable?
Well, size is a big factor. T-Garden B is roughly the same size as Earth. Also, it orbits within its star's habitable zone, that sweet spot where temperatures could allow liquid water to exist on the surface.
Right.
However, this is what the tidal lock throws a wrench into things.
Right, that dramatic temperature split. So are scientists picturing life huddled in some kind of twilight zone between the extremes, maybe with creatures sporting heat-resistant scales on one side and thick fur on the other?
It's a possibility. Some theories suggest that life could indeed exist in that narrow band between eternal day and night. Others propose that deep oceans, if they exist, could provide a more stable, temperate environment. Imagine underwater ecosystems thriving in complete darkness, powered by geothermal vents instead of sunlight.
Okay, now that's an image that'll stick with me. But even if Tea Garden B manages to regulate its temperature swings, isn't there another issue? I remember reading something about its star being a bit of a troublemaker.
You're thinking about the fact that T-Garden is a red dwarf star. These stars are much smaller and cooler than our sun, but they're also known for their dramatic outbursts of energy called flares.
So it's like living next door to a neighbor who loves setting off fireworks. Except these fireworks are powerful bursts of radiation, not exactly ideal for a budding ecosystem, right?
Exactly. These frequent flares could bathe T-Garden B in harmful radiation, making it a much harsher environment than initially thought. It's a reminder that habitability isn't just about being the right distance from a star, it's also about the star's temperament.
Talk about a cosmic reality check. It seems like this planet is full of contradictions. Earth-like, yet alien, potentially habitable, yet constantly bombarded with radiation. It makes you realize how diverse and complex planetary systems can be.
Absolutely. And speaking of complexity, let's shift gears to a planet that takes unpredictability to a whole new level. Kepler 413b. This gas giant has a rather peculiar habit. It disappears.
Wait, disappears like a cosmic magic trick? Did it fall into a black hole or something? How does a planet just vanish?
Not quite a magic trick, but its movements are definitely baffling. Every 11 years, Kepler 413b literally disappears from our telescope's view. The culprit. Its incredibly wonky orbit,
Oh, wow.
caused by the gravitational tug-of-war from nearby stars.
No. So it's not actually vanishing, more like playing an elaborate game of cosmic hide-and-seek with astronomers. I'm guessing this gravitational tug-of-war makes for a pretty wild ride on the planet itself.
You could say that. Imagine a world where seasons are completely erratic and the climate shifts dramatically. You could be basking in springtime one moment and plunged into an ice age the next. Add in the potential for planet-scale storms and hurricanes, and you've got yourself a recipe for a truly chaotic world.
Yeah, I think I'll stick to Earth's relatively predictable seasons. Speaking of wild, unpredictable, didn't you mention something about a planet where it rains molten rock?
Ah, yes. You're thinking of K2141b. This planet is a study in contrasts, with a day side so hot it melts rock into a lava ocean,
Oh, wow.
and a night side so cold it's a frozen wasteland.
Okay, so we've got fire and ice, but where does the molten rock rain come in?
Picture this. Supersonic winds whipping across the planet, carrying vaporized rock from the scorching day side to the frigid night side. As this vaporized rock hits the freezing temperatures, it condenses and falls as, you guessed it, molten rock rain.
I'm starting to think extreme is an understatement when it comes to describing these cosmic oddities. It's almost hard to believe places like this actually exist.
It is mind-boggling, isn't it? But that's the beauty of the universe. It constantly challenges our understanding of what's possible.
Okay, I need a break from all this intensity. Do we have any cosmic wonders on our list that are a bit easier on the eyes? Something a little less apocalyptic?
You bet. Let's take a trip to Super Saturn, or J1407, a gas giant that puts on a dazzling display with its colossal ring system.
Super Saturn, that's a name that screams spectacular. What makes this planet's ring so super? Are we talking like Saturn's rings, but with extra bling?
Imagine Saturn's rings, but 640 times larger. We're talking a ring system so vast that if it were around our sun, it would stretch out farther than the orbit of Venus.
Wow, I'm trying to picture that. Our night sky would be dominated by these massive, shimmering rings. It'd be like having a front row seat to a cosmic light show.
And these rings aren't just massive, they're incredibly complex. Scientists believe moons might be forming within these rings, giving us a glimpse into the early stages of planetary system formation.
So it's like a celestial nursery, with baby moons being nurtured within these giant rings.
Exactly. It's a humbling reminder that the universe is constantly evolving, with new worlds being born even as we speak.
This is incredible. We've covered so much already, from fiery hellscapes to planets that play hide and seek. But before we get lost in the cosmic vastness, you mentioned earlier that not all planets have stars. I have to hear more about those rogue planets, those lone wolves of the cosmos. What's their story?
They are truly fascinating. Imagine planets adrift in the vastness of space, untethered to any star, wandering the galaxy in perpetual darkness. They're like cosmic orphans, shrouded in mystery. We're not entirely sure how they form, but some might have been ejected from their original solar systems, while others might have formed independently.
So no days, no nights, no seasons, just eternal darkness and cold. Do they even have weather? It's mind-boggling to think about what it would be like on a rogue planet.
Well, it's true they wouldn't have days, nights, or seasons in the way we experience them, but that doesn't mean they're static and lifeless. They could still have internal heat sources,
Oh,
perhaps from radioactive decay or tidal forces, creating interesting dynamics beneath the surface.
so you're saying there's a chance that even in that eternal darkness, there could be some kind of activity, maybe even life.
It's a possibility that we can't rule out. Take, for instance, Y08550714. It's a rogue planet just 7 light years away, practically a next-door neighbor in cosmic terms, and it might have the right conditions for liquid water beneath its surface, even without a star to warm it.
7 light years away and potentially harboring liquid water, that's mind-blowing. You're telling me our galaxy could be teeming with these rogue planets, some of them maybe even habitable, just cruising through the darkness.
It's a tantalizing thought, isn't it? And it speaks to the incredible diversity and endless possibilities that the universe holds. But before we dive deeper into the world of rogue planets,
Okay.
let's take a detour to the birthplaces of stars, stellar nursery.
Oh, I love this part. It's like witnessing cosmic creation in action. Tell me, what are these stellar nurseries like? Are they serene and peaceful, or are they more like cosmic mosh pits?
Picture this. Vast, swirling clouds of gas and dust, stretching for light years, cold and dark, yet brimming with potential. These clouds are the cosmic cradles where stars are born. Gravity is the architect, pulling particles together, slowly but surely.
So it's like a giant cosmic construction site, with gravity laying the foundation for a star to emerge.
Exactly. As these clumps of gas and dust grow denser, they collapse under their own gravity, and the temperature and pressure at the core increase dramatically. Eventually, it gets so hot and dense that nuclear fusion ignites and a star is born.
And I'm guessing this birth isn't exactly a quiet affair, right? Is there a cosmic version of labor pains?
You could say that. The birth of a star is a chaotic and violent process. As the star forms, it blasts out powerful jets of gas that can travel for light years, creating these spectacular structures called Urbig Haro objects.
Her big Haro objects, those sound familiar. Are they those dazzling, colorful streaks you see in images from space telescopes?
That's right. They're essentially shock waves created by those high-speed jets of gas slamming into the surrounding interstellar medium. As the gas heats up and ionizes, it glows brilliantly, creating some of the most awe-inspiring images in astronomy.
It's amazing to think that those stunning images are actually snapshots of star formation in action, captured billions of years after the event, and to think one of the most famous stellar nurseries is visible to the naked eye.
You're talking about the Orion Cloud, right? That faint, fuzzy patch in the sword of the constellation Orion is actually a vast star-forming region teeming with newborn stars and those spectacular Herbig-Haro objects.
The next time I look up at Orion, I'll be seeing not just a familiar constellation, but a cosmic nursery full of stellar newborns and the echoes of their dramatic births. That's pretty incredible.
And within the Orion Cloud, there's an even more captivating sight. Barad's Loop.
Barad's Loop.
Right.
Okay, now you've got me intrigued. What makes this loop so special?
It's a glowing nebula, a vast ethereal structure shaped by a series of supernova explosions. Imagine a giant bubble of gas and dust expanding outward, illuminated by the remnants of dead stars. It's a testament to the cycle of cosmic death and rebirth, played out on a grand scale.
So stars die, explode, and then their remains create these breathtaking nebulae that eventually give rise to new stars. It's like a cosmic phoenix rising from the ashes.
That's a beautiful way to put it. Barad's Loop is a stunning reminder that even in destruction, there's creation. The universe constantly renews itself, finding new ways to shine.
You know, we've explored some truly mind-bending phenomena today, from planets with extreme conditions to rogue planets wandering the void, and now stellar nurseries and supernova remnants. It seems like the universe is all about pushing boundaries, defying expectations, and embracing the unexpected.
You've hit the nail on the head. The universe is a vast and wondrous place, full of surprises and mysteries waiting to be unraveled. And the more we explore, the more we realize how much more there is to discover.
It's both humbling and exhilarating. But we've covered a lot of ground in this first part of our deep dive, so let's take a breather, and we'll be back in part 2 to delve even further into the universe's oddities.
Welcome back, space explorers. Ready to delve deeper into the cosmic oddities that challenge our understanding of the universe?
You bet. I'm still reeling from those molten rock rain showers on K2141b. What else have you got in store for us?
Let's switch gears from extreme heat to the ultimate cosmic chill. The realm of rogue planets. We touched upon them earlier. These free-floating worlds, untethered to any star wandering the galaxy like cosmic nomads.
Yeah, the idea of planets just drifting through the vastness of space, shrouded in eternal darkness, is both fascinating and a little eerie. But you mentioned that some scientists believe these rogue planets might actually be quite common.
That's right. While we can't directly observe them easily since they don't emit light like stars, some estimates suggest there could be more rogue planets in our galaxy than stars.
Whoa, more rogue planets than stars. That's mind-boggling. So for every twinkling point of light we see in the night sky, there could be multiple dark unseen worlds drifting out there.
Exactly. And that raises some intriguing questions. How do these rogue planets form? Could they harbor life even without a star to provide warmth and light?
Okay, I have to know more about how a planet ends up going rogue in the first place.
Mm-hmm.
Is it like a cosmic eviction getting kicked out of its solar system?
It's a possibility. One theory is that during the chaotic early stages of a solar system's formation, gravitational interactions between planets can sometimes fling one of them out into interstellar space like a billiard ball knocked off the table.
So it's a case of planetary sibling rivalry gone wrong.
In a sense, yes. It's a reminder that even in the seemingly orderly realm of planetary systems, chaos and chance can play a significant role.
And once a planet goes rogue, it's just adrift in the darkness forever. No chance of finding a new home around another star.
It's unlikely, but not impossible. The vast distances between stars make it incredibly improbable for a rogue planet to be captured by another star's gravity. But hey, stranger things have happened in the universe.
Speaking of strange things, what about the possibility of life on these rogue planets? It seems like it'd be a long shot given the lack of sunlight and warmth.
It's certainly a challenge, but not necessarily a deal breaker. Remember, life as we know it on Earth relies on sunlight for energy. But there are other sources of energy that could potentially support life. For instance, some scientists speculate that geothermal energy generated from the planet's internal heat could create oases of warmth and liquid water beneath the surface of a rogue planet.
So instead of basking in the sunlight, life on a rogue planet might be huddled around geothermal vents, like those found in the deepest parts of Earth's oceans. It's amazing to think that life could find a way to thrive even in the most extreme and unexpected environments.
It really speaks to the resilience and adaptability of life, doesn't it? And it broadens our perspective on what habitable truly means. It might not be the lush, sun-drenched world we're used to, but life could still find a way to exist in those dark, hidden corners of the universe.
I'm starting to feel like our definition of weird needs an update when it comes to the cosmos. Okay, so we've got these potentially life-harboring rogue planets wandering the galaxy. But let's shift gears back to the more familiar territory of stars. We talked earlier about stellar nurseries, those vast clouds of gas and dust where stars are born. But what happens after a star is born? Does it just hang out there forever?
Not exactly. Stars, like everything else in the universe, have a life cycle. They're born, they live, they age, and eventually they die. And the way a star dies depends largely on its mass.
So it's like a cosmic version of live fast, die young. The bigger the star, the shorter its lifespan.
That's the general idea. Massive stars burn through their fuel much faster than smaller stars, leading to more spectacular and shorter lives.
Okay, but what about those spectacular deaths? You mentioned supernova explosions earlier. What exactly happens during a supernova, and what's left behind?
Imagine this. A star, having exhausted its nuclear fuel, collapses under its own immense gravity. This collapse triggers a catastrophic explosion that blasts the star's outer layers into space, creating a dazzling display of light and energy that can outshine an entire galaxy for a brief period.
Okay, talk about going out with a bang. But what about the aftermath? Is it just cosmic debris scattered across space?
It's more than just debris. Supernova explosions are responsible for seeding the universe with heavy elements, the building blocks of planets, and ultimately life itself. They're like cosmic recyclers, transforming the ashes of dead stars into the ingredients for new stars and planetary systems.
So in a way, we're all made of stardust, forged in the fiery hearts of stars that lived and died billions of years ago.
Precisely. Every atom in your body, every element on this planet can be traced back to those stellar furnaces. We are quite literally children of the stars.
That's a profound thought, and it makes those supernova explosions seem a little less destructive and a lot more creative.
It's all part of the grand cosmic cycle. And these supernova remnants, the expanding clouds of gas and dust left behind after the explosion, aren't just beautiful to look at. They're also valuable laboratories for astronomers.
Okay, so how do astronomers use these supernova remnants to study the universe? Are they like cosmic time capsules holding clues to the past?
Exactly. By studying the composition and structure of these remnants, astronomers can piece together the history of the exploded star, learn about the processes that led to its demise, and even glean insights into the evolution of galaxies.
It's amazing how much information can be gleaned from these cosmic leftovers. But speaking of leftovers, we've still got more cosmic oddities to explore in our deep dive. So let's take another break and we'll be back in part 3 to uncover even more wonders of the universe. Welcome back, fellow space explorers. Our cosmic journey has taken us from planets with molten rock rain to stars that explode with the energy of a billion suns.
Yeah, it's been quite a ride.
We've explored the strange and the spectacular, pushing the boundaries of what we thought was possible in the universe.
That's
I have to admit, my cosmic curiosity is officially piqued.
good.
But before we wrap up our deep dive, I want to touch on something we haven't discussed yet. Black holes.
Ah, black holes. Those enigmatic cosmic beasts that warp space and time. They're perhaps the ultimate cosmic oddity objects, so dense that not even light can escape their gravitational pull.
I've always found black holes both terrifying and fascinating. It's like staring into the abyss of the unknown.
I can see why you'd say that.
But what exactly are they, and how do they form?
Okay, so imagine a star, many times more massive than our sun,
Okay.
reaching the end of its life. As it runs out of fuel, its core collapses under its own immense gravity, crushing itself into an infinitely small point called a singularity.
So it's like the ultimate cosmic implosion with all that matter compressed into a tiny, infinitely dense point.
Exactly. And the gravitational pull of this singularity is so strong that it warps the fabric of space-time around it, creating a region from which nothing, not even light, can escape. Hence the name black hole.
Okay, that makes sense. But if they're black and nothing can escape, how do we even know they exist?
It's a good question. While we can't directly observe black holes themselves, we can detect their presence by their effects on their surroundings. For instance, if a black hole is pulling in gas and dust from a nearby star, that material heats up and emits X-rays, which we can detect with telescopes.
So it's like seeing the shadow of a black hole, the outline of its presence, revealed by the things it consumes.
That's a good analogy. And by studying these X-ray emissions along with other observations, astronomers can learn about the mass spin and other properties of black holes.
It's incredible how scientists can piece together the puzzle of black holes from these indirect clues. But what about the idea of black holes as cosmic destroyers, swallowing up everything in their path? Is that accurate?
It's a common misconception fueled by science fiction. While black holes have incredibly strong gravitational pull, it's not like they're cosmic vacuum cleaners sucking up everything around them.
So it's more about proximity. If you get too close, you're in trouble, but otherwise you're safe.
Exactly. The gravitational influence of a black hole, like any object with mass, depends on distance. If you're far enough away, its gravitational pull is no different from that of any other object of the same mass.
That's reassuring. I wouldn't want to accidentally wander too close to a black hole. But, with all this talk of cosmic death and destruction, it's easy to forget that the universe is also a place of incredible beauty and creation.
You're absolutely right. And there's no better example of that than nebulae, those vast luminous clouds of gas and dust that we touched upon earlier.
Yeah, we talked about Broad's loop formed by supernova explosions, but there are other types of nebulae, right?
There are. Some nebulae are emission nebulae, like Broad's loop glowing brightly as the gas within them is energized by nearby stars. Others are reflection nebulae, reflecting the light of nearby stars like cosmic mirrors. And then there are dark nebulae, which are so dense that they block the light of stars behind them, appearing as dark silhouettes against the brighter background.
So it's like a cosmic art gallery with all these different types of nebulae showcasing the interplay of light, gas, and dust.
Exactly. Each nebula is unique, a testament to the dynamic and ever-changing nature of the universe.
It's a reminder that even in the vastness of space, there's artistry and wonder to be found. And as we wrap up our deep dive into the universe's oddities, I can't help but feel a sense of awe and inspiration.
I agree. Exploring the universe is like embarking on an endless adventure filled with surprises, challenges, and moments of breathtaking beauty.
And the more we learn, the more we realize how much more there is to discover. This has been an incredible journey through the cosmos, exploring everything from bizarre exoplanets to the mysteries of black holes and nebulae. We've seen how the universe constantly challenges our understanding of what's possible, and that's what makes it so captivating. We hope you've enjoyed our deep dive into the universe's oddities, and we encourage you to continue exploring the cosmos with us. Don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel for more cosmic adventures. Thanks for listening.